Welcome to the pre-calculus notes for Chapter 2.6 titled Rational Functions, Asymptotes, and Graphing. Go ahead and write your name and what period you're in. All right, so today we're going to be talking about rational functions. A rational function can be written in the form a function f of x, where your numerator is your p of x and your denominator is your q of x. And the q of x cannot be 0 because you can't have a 0 in the denominator. All right, so we're going to be graphing these rational functions. And so there's a couple things we need to know about the graph because they're a lot more complicated than just graphing a line or just graphing a parabola. Okay, there's all kinds of different parts. Okay, so we need to for some of them, think of just the numerator or think of just the denominator. And so here's how it works. All right, so we need to find things called vertical asymptotes. And the vertical asymptotes are going to be where there are zeros for the q of x. That's the denominator, where x squared minus 4x minus 12 is equal to 0. So to get the vertical asymptote, VA, vertical asymptote, we're going to factor this trinomial. So the factorization is x minus 6 and x plus 2. Where are each of those 0? It's the opposite of this, which is positive 6, the opposite of this, which is negative 2. So there's going to be vertical, meaning straight up and down, a vertical asymptote at negative 6 and a vertical at positive 6 and a vertical asymptote at negative 2. So those are lines going up and down, and the graphs are going to come super close to those lines, but they're never going to touch them. Okay. Number 2, the graph of the function has at most one horizontal asymptote as follows. Okay, so horizontal is this way, vertical is this way, horizontal is this way. Okay, and there are 3 different scenarios. If n is less than m, the x-axis, which is y equals 0, is the horizontal asymptote. If n and m are equal, then it's going to be a divided by b, and we'll talk about that in a minute, is going to be your horizontal asymptote. And if n is greater than m, the graph of the function has no horizontal asymptote. So in this case, the n, which is if we look at the largest exponent here, is 1. So the x to the first power, even though you can't see the 1, it's 1. Okay. The m is the largest exponent of the denominator. So here's your denominator. The largest exponent is 2. So we have 1 is less than 2. So it follows this first condition, which says that the horizontal asymptote is going to be y equals 0. So you just say that the horizontal asymptote is y equals 0. That means that the graphs are going to come really close to it, but never actually touch it. It might look like it's touching it, but it's not. It's getting super, super close, but not touching it. Okay, we're also going to have X-intercepts. We're going to find the value that makes the numerator 0. Okay, so the numerator, in this case, is x minus 5. So to find the x-intercept, we set x minus 5 equal to 0, add 5 to both sides, and we get x equals 5. All right, and then the y-intercepts, we're going to plug in 0 for x. Okay, so plug in 0 here, plug in 0 here, plug in 0 here. 0 minus 5 simplifies to negative 5. 0 squared is 0. 4 times 0 is 0. 0 minus 0 is 0. And 0 minus 12 is negative 12. So we have a negative over a negative, so we just simplify it to positive 5/12. That's a fraction. It's almost 1/2. Okay. So on the y-axis, you're going to have a point roughly at 1/2, 5/12. Okay. All right. So if you're going to graph it, you are going to have those vertical asymptotes, one at negative 2 in purple here. So it's this dashed line. and one at, I believe it was positive 6. Why is this not? Okay. One at positive 6, so that's your other vertical asymptote. We had a horizontal asymptote right here at y equals 0. So that's dashed in there in purple as well. It's harder to see because it's on the axis, which is already thicker, right? Okay, so the domain is going to be all real numbers except when x is negative 2, because there's an asymptote there, and except when x is equals 6, because there's an asymptote there. Now, to determine what's happening in different spots, you can plug in numbers. For instance, if you want to see what's happening to the left of your negative 2 asymptote, you could plug in negative 3, and you'll get negative 8/9. To determine what's happening to the right of your asymptote at positive 6, you could plug in 7, and you would get 2/9. So you would have these points, one little point here, one little point here, and that would show you what the graphs are doing. You can also click over and go in Desmos and type in your function. Nope. Let me make that just a little bit bigger. No. Okay, so here is the graph of x minus 5 over x squared minus 4x minus 12. And I've got an asymptote here at negative 2, asymptote at positive 6. You see how the graphs are getting super, super close. They almost look like they're on it, but they're not. I mean, if we zoom in, you'll see that there's more space in there, okay? And you'll be able to graph it, okay? They're a little tricky to type in Desmos, but you can always use the little pop-up keypad, and that'll help you type it in. And if you mess it up, just delete it and start it again, okay? All right. All right. Here's the next problem. We're going to have the function of x equals 3 over x plus 2. So to get the vertical asymptote, we're going to set the denominator equal to 0, subtract 2 from both sides, and you get x equals negative 2. So at negative 2, you're going to dash in a vertical asymptote. The exponent, the largest exponent of the numerator of your x variable is 0, because there is no x term. The largest exponent of the denominator of the x term is 1. So in this case, 0 is less than 1. And again, you're going to have a horizontal asymptote at y equals 0. So it's dashed in there. Again, it's on top of the axis, which is already a little bit thicker, so it's harder to see. There is no x-intercept because 3 does not equal 0. It's just, there is no, they're both going to get really, really close to the x-axis, but they're never going to cross it. The y-intercept, where is it going to cross this y-axis? It looks like it's here, right? So you're going to plug in 0 everywhere x is at. There's only one x, which is right here. So 3 over 0 plus 2, which is 3/2. And as I predicted, about 1.5. 3/2 is 1.5. If you're asked for the domain, you're going to say all real numbers except for when x is equal to negative 2. And if you're trying to figure out something happening, plug in a number over here or a number over here, and it's going to give you the exact value. Okay, so let's look at in Desmos. If you wanted to type that one in Desmos, there it is. Okay. All right, the next rational function is 6 over x minus 4. To get our vertical asymptote, we take that denominator of x minus 4, set it equal to 0, add 4 to both sides, and you have a vertical asymptote at x equals 4. To get the horizontal asymptote, the largest exponent on the x term in the numerator is 0. The largest exponent on the x term in the denominator is 1. The 0 is less than 1, so there's a horizontal asymptote at y equals 0, going right here in blue. There's no x-intercept because 6 does not equal 0. And to find the y-intercept, we plug in 0. So 6 over 0 minus 4 is 6 over negative 4, which is negative 3/2. It's about right there. Okay. And if you want to plug it in Desmos, you just type it in. There it is in green. Okay. All right. Next one. Okay. So now we've got our function of x. This time we have x plus 2 over the trinomial x squared plus 3x minus 4. So to get the vertical asymptote, we're going to set the denominator equal to 0, and this time we have to factor. So this factors to x plus 4 and x minus 4. If you need help remembering how to factor, stay in a Zoom and let me know, and I can help you with those, okay? So this one should be negative 4, this one should be positive 1, so you're going to have an asymptote at negative 4, x equals negative 4, that's this blue line right here, and positive 1, that's this line right here. And our horizontal asymptote, the exponent of the numerator is 1, the exponent of the denominator is 2, 1 is less than 2, so your horizontal asymptote is at y equals 0. The x-intercept is where the numerator is equal to 0, so subtract 2 from both sides. And if you want to find out some points, plug in some values and get those. Okay? Oh, there we go. All right. Next function is 4x minus 5 over x plus 3. Okay. So to get the vertical asymptote, we're going to take the denominator, set it equal to 0, subtract 3 from both sides, and there's your your vertical asymptote, okay, in green. That means the domain is going to be all real numbers except for where x is equal to negative 3. Okay, horizontal asymptote, the largest exponent of the numerator is 1, the largest exponent of the denominator is also 1, and so 1 is equal to 1. So in this case, you're going to take the value, and so in this case, you're going to take the value of the algebraic terms, drop off the numeric terms, so you'd have 4x over x, which simplifies to 4 over 1, and 4 over 1 is 4. That means your horizontal asymptote is now at x equals 4. So instead of being on top of the x-axis like it was on all the previous ones, it's up here in the green dash, going from left to right. Okay, to find out your x-intercept, set the numerator equal to 0 and solve. To find the y-intercept, plug in 0 everywhere you see x, and you'll get negative 5/3. That's going to give you some points. Okay, point here, point here. And then if you want to graph it, you can come over to Desmos. Which one is it? It looks like this one. It's the one here in black. Oh, and let me squeeze in. Oh, wrong way. There it is. Okay. All right. All right. G of x is x plus 3 over x squared minus 4. So for the vertical asymptote, we want to take the denominator, set it equal to 0, and solve. We get plus or minus 2, so 1 here and 1 here. Horizontal asymptote, the exponent for the numerator is 1, the exponent for the denominator is 2. So 1 is less than 2, which means our horizontal asymptote is going to be at y equals 0. Okay, and let's see. If we want to get an x-intercept, we take the numerator and set it equal to 0 and solve for x. So we're going to have an intercept at negative 3. 1, 2, 3. So there's 1 right there. Okay, good. And then y-intercept, plug in 0 and solve. So 0 plus 3 is 3. 0 squared is 0. 0 minus 4 is negative 4. So negative 3/4. So about right there. That's that point there. And then if you want to find out some points, plug them in and you'll get some values, or you can go to Desmos and graph it.